All right, today we're going to talk about inductive and deductive reasoning. So inductive reasoning is arriving at a conclusion based on observations of specific examples. So if I'm looking at something and I see something happening, I want to base it on just those observations, not on any prior knowledge, okay? Deductive reasoning is the process of proving a specific conclusion from one or more general statements. So this is actually like that, kind of like that solving process or showing that two things are equal. Inductive reasoning is just kind of looking at a couple examples and then kind of expressing a conclusion from that. So we're going to look at some inductive reasoning here. So the first thing is we want to talk about is a counterexample. So a counterexample is something that proves a statement is false. Okay, so here I have two equations here. I have 47 plus 73, that equals 120, and 56 plus 46 equals 102. Now, somebody may look at this and go, oh, well, those are two-digit numbers being added together, and they always are a three-digit number. So their conclusion might be, is the sum of two-digit numbers always a three-digit number. And to prove this false, what you're going to do is you're going to find a counterexample that shows that's not true. You can use any counterexample. So what I'm going to do is I'm going to pick a two-digit number. Let's say 15. I'm going to pick another two-digit number. Let's go 23. I'm going to add those together and see if I get something that's not a two-digit number. So this gives me 8, 38. 38 is not a three-digit number. So this counterexample shows that not always is the sum of two-digit numbers a three-digit number. So this is a counterexample that proves it's not true. Okay, so we're going to use inductive reasoning here in our patterns. That's part of what mathematics is finding that pattern. So here we have 3, 12, 21, 30, 39. I want to find that next number, and I want to be able to identify the pattern. What is happening here? Ideally, we would like to be able to convert this into a mathematics equation, but we're going to settle for just kind of describing it. Okay? So the first thing we want to do, and we're looking at patterns, a lot of times is just see if we're adding or subtracting the same amount, or is it multiplying or dividing, or is it something a little bit harder? Okay, so here I notice that to go from 3 to 12, okay, two different ways I can get there. I can either add 9 or multiply by 4. So then I have 12 and 21. Well, the way I get from 12 to 21 is add 9. So I've consistently added 9, and then I check that throughout. 21 plus 9 is 30, 30 plus 9 is 39. So it looks like my pattern is adding 9 to the previous one. So 39 plus 9 is 48. Okay. Now I'm going to look at my next one. Okay. So I look between 3 and 4. I notice that there's a difference of 1. Okay. I'm going to look at my next set. I'm going to look at 4 and 6.